This one, like in general, what does the binomial expansion say? I think it starts with a 1 maybe?
Yeah.
Starts with a 1 and then it's plus what?
Plus p
X, yep, plus p times.
Basically p factorial.
Yeah, but you stop and then what's on the denominator here? 2 factorial x squared, right?
Yeah.
And then what's the next one? The pattern continues. If you remember the first 3 terms, it's just the same pattern. What's the next one? P times 1 times p minus all over x to the third, and it keeps going like that, right? So in this case, if you're doing this, what's the p-value on this one? 3. So the p-value is 3. So when you start plugging this in right here, this 3 value, you end up with 1 plus what? 3x plus 3 times 2 over 2 factorial x squared plus what? 3 times over 3 factorial x to the third. What's the next term going to be? This is very important. It is, but why? Because you get 3 times 2 times 1 times 0 over, and you could write the next one, couldn't you? What would the next one be? 3 times 2 times 1 times 0 times all over 5 factorial. But what happens once you hit that 0? All of these terms from here on out are going to be 0. So yes, if this was what you're asking about, Sabrina, you should clean this one up, and you get 1 plus 3x plus what? 3x squared plus x cubed. There it is. You've now multiplied out 1 plus x, you've cubed it without having to actually reverse factor, which is a term I heard recently that I kind of like. Does that kind of make sense, everybody? This is actually kind of helpful. Like once you internalize this, everybody, once you lock this into your memory right there, the general form, this is super helpful. You can crank through expansions really nicely. Infinity of the next term, right? What's the next term going to be? X to the n plus 1 over 1 factorial all over x to the n over n factorial. So that's going to be the limit as n goes to infinity of x to the n plus 1 over n plus 1 factorial times n factorial over x to the n. What cancels there? A whole lot. That goes away. And what are you left with? Oh, that just kind of kills the factorial, right? And then you get x to the n. That goes away. So what are you left with here? The limit as n goes to infinity of what? X over n plus 1. Now, x is finite. It stops. It's something you choose. But what happens to n? So this is always going to be going to what? 0. And 0 is always less than 1. So what's the radius of convergence going to be? Infinity. Which is great because otherwise we wouldn't be able to use this Taylor polynomial to be e to the x. This tells us that for whatever x value we choose, this infinite Taylor series, this Taylor polynomial, will be exactly e to the x. If I asked you to find... So does that look familiar? Does that have a connection to 35? What happens when you plug in a certain value into this? What do you want x to be in this? If you plugged in 2, what do you get? E squared is equal to 1 plus what? 2 over 1 factorial plus 2 squared, which is 4 over 2 factorial plus 2 to the third, right? Does that match? Yes, so what does this equal? What does this infinite sum equal? E squared. That's what that infinite sum equals. It equals e squared. That is e squared. We have a very limited number of Taylor polynomials right now. So if it asks you to recognize a Taylor polynomial, it's a pretty narrow set. So what is this one? Do you remember? If it's 3, 5, it's the odds. Which one is this? This is what? It's sine. This is sine of x evaluated at something. On top, you have x squared, so it's 1, 1, 1, 1, 1. Which one? What the sine of what is 1? What's it going to be? Make that turn into this one right here. X is equal just to 1, right? So it's not sine of pi over 2. This is equal to sine of what? 1. This big explosion is just sine of 1. It seems messy, right? It seems messy. It seems x minus
1 over 2.
You have to integrate. What's it going to be?